professional on that. So I'll start. So I'm Fred with Revision Energy. I am our digital marketing manager. Means I get to handle our Facebook ads and website, social media, everything related to our company's presence on the web. Occasionally appear in person and do stuff out, not in front of behind a computer screen, which is fun. Like being here today. It is an honor to be here because I am a USM graduate. I was born in Maine, went to public school in Maine, went to public college in Maine, and got a job in my major, so it can be done. And it's a really fun one. This is the Thomas College. Currently has the largest photovoltaic array in the state of Maine that we got to install last year, 127 kilowatts. And this talk is really geared about the kind of the bigger picture vision of our fossil fuel dependency and carbon emission situation, and how solar fits in as a solution as opposed to maybe the nuts and bolts of solar. But if you do have questions about, how solar panels work and stuff, that's also fun. I can talk about it afterwards. So the first kind of really important thing to get in your head is that we have to sort of burst a little bubble about Maine, and that everyone thinks of Maine as a super green state. We have beautiful national park, we have beautiful woods and forests and streams. We also have a really bad carbon addiction problem. So if you look at our actual oil consumption, it's the highest per capita in New England, and you see that nationally we're number 28 in terms of the overall consumption of fossil fuel energy and CO2 emissions. So we think of ourselves as very, very green, but we're not at all. A big part of that's because we heat our homes predominantly with oil, and because we drive a lot. We commute far to go to work, to go to school, and that results in a high carbon footprint for our otherwise green state. For example, we see all these oil tankers, hundreds of them here, entering South Portland. It's the second most busy port on the East Coast for oil imports, dumping into this kind of farm that you see in South Portland. So that's not terribly pretty, and that's happening every single day here in Casco Bay. It's hard sometimes for people to visualize like what CO2 emissions are and why they're, what the significance is. So here you see a gigantic blob, which is the actual volume of the CO2 emissions put out by a typical home relative to the size of that typical home, and that's a result of burning over 800 gallons of oil to heat the home and heat the home's hot water. We basically have a completely free pass to dump this stuff into the environment, but if you were going to put that amount of trash into a river each year, you'd be arrested. You'd be, if you had that much dump on your lawn, you'd not be allowed to live in your neighborhood. But if you dump that much CO2 in the atmosphere each year, go for it. That's just what we do. So this is a slide that helps sort of put that in perspective, how much CO2 comes out of each house each year. We also seem to have this fairy tale of natural gas, that it's going to be the wonder fuel that saves us. It's not really all that pretty when you start digging into it. Somewhere around 5 million gallons of water is pumped at high pressures into the earth to crack this shale and send this stuff bubbling up to the surface. That water goes from being clean drinking water into a waste product, primarily filled with all sorts of nasty stuff. The stuff that they actually publish about includes, to a large extent, hydrochloric acid and chlorine and antifreeze. So, not particularly wonderful stuff that we know is going into the water. We're turning clean drinking water into waste product. We know there are slightly better and slightly worse ways to be managing it, but overall, it's not this fairy tale of happy CO2 savings that's environmentally neutral. It's a pretty invasive process, and really only a stopgap measure. So here's an example of what one of these operations looks like. It's not without a pretty big eco footprint. It's also not the safest stuff to use. So this is the ash of a house in Bath, Maine, that had a propane tank explosion, and you see that within spitting distance of the explosion, there's 3 more tanks outside people's homes. So it's this does happen. It doesn't, tanks of compressed gas do explode. So that's not benign. And this is another wonder fuel is the carbon tar sands up in Alberta operation. The folks from 350 Maine are here can attest about why getting this pumped through Maine is a horrible idea. This one plant consumes enough energy to fuel 3 million homes, to heat 3 million homes. So we're consuming energy that we could be using to heat our homes to extract this form of extremely highly carbon-embedded oil, and desperately trying to come up with any crazy cockamamie scheme we can to get it out of Alberta and off to the world at a cost of about 4 times more carbon emissions per unit of energy than typical oil. So as if, the basic reality that the fossil fuel economy is having to deal with is that the easy forms of fossil energy have been used up. And we are not really, we don't go about with the mission of saying, oh, fossil fuels are evil, fossil fuels are terrible. Fossil fuels have allowed us to develop the economy that we have today, to build the technology that we have today. But we should not be so captivated on the fuels that allowed us to get here that we're going to burn every last ounce of it on the planet without changing our strategy. That's an insane strategy. What we do have is enough of this stuff left to try and transition to a better way. Without even talking about climate, which is worth considering. This rather disturbing graph of the CO2 concentrations relative to temperature change, relative to fossil fuel burning in the environment. I mean, that's, we still go up against climate change deniers when, 97% consensus among the scientific community. There's no question, there is no room for doubt. This is a reality. And those of you who saw Bill McKibben speak or follow 350 have seen this graph, which is quite disturbing, where even the most conservative governments, such as the U.S., believe that 2 degrees centigrade warming is about all we can handle without huge environmental consequences. We're already about halfway there. We have about 565 gigatons of CO2 we can burn before we're going to hit the pain threshold. We know that about 5 times that amount already is known, already exists. If we burn just the CO2, just the oil that we have known reserves, we're going to be way, way past our safe zone into the point of of no return. So that's the existential crisis of what we face with climate change. And what do we do about that? Well, we got our happy lawn. We're just going to talk about the solar potential in the region. So this is not Old Orchard Beach.
What?
This is the French Riviera. The reason we have a picture of the French Riviera is that that's as much sun as Maine gets, relatively speaking. Despite what Fox News tells you, if you look at the latitude of Maine and the south of France, we're about equidistant. So though our regional weather is different, from a solar insolation perspective, we're more like the south of France than we are, say, Germany. Yet in Germany, which is more like Caribou in terms of solar potential, you see this is a typical neighborhood where I think close to about 20% of their power production comes from solar photovoltaic. Not because it's so sunny, but because they've had policies that encourage this and huge, appreciable investments. As of the Fukushima disaster, Germany made a commitment to eliminate their use of fossil fuels, of nuclear energy, rather. And so, here's a solar farm, and we certainly like to see more distributed sources of PV, rooftop PV, where power is needed. But certainly compare the impact of having a bunch of solar panels sitting in the field compared to a bunch of nuclear waste in the field, and there's a pretty strong appeal there. So again, to go against Fox News, which seems to not be able to, look up any sort of basic scientific information, Germany is, again, maybe like the very northern part of Maine. It's more like Alaska compared to even southern Maine is really quite a nice zone for solar photovoltaics. You know, we're not the southwest of the United States, but we still have an appreciable amount of energy that we can harvest here from the sun. The other sort of myth that we go up against often is that solar panels are expensive. In reality, they have been on a pretty steep decline to the point where today the cost of solar panels is barely above the actual raw cost of silicon, aluminum, and glass, the three major components of them. There's a law-ish called that every time the production capacity doubles, the cost drops by about 20%. You know, this curve, you know, at some point we're going to hit some sort of bottom, but at this point, the cost of solar panels continues to drop. So you see that, you know, compared to 5 years ago, we're about half the cost today, which is...
I'm sorry, you said in the last 5 years?
In the last 5 years. Since 2008, the cost has dropped by more than half. Yes. Yes, exactly. Well, yeah, I had a system installed in 2008, and we tripled the size of it for less than I paid for the original system 4 years later. So this is not, you know, we're no longer in solar as a fairy tale. We're in solar as an economically viable choice for power generation, to the point where this is a typical graph that we'll try to come up with when looking at a commercial scale project, where if you look at this as an investment over 20 years, it comes out to be about a third of the cost of paying for comparable grid electricity. So, you know, if you can afford to buy your power forward, and if you're assuming an increase of power of 4% year on year, which is fairly consistent with our history, you see that you're going to be paying 6 cents a kilowatt hour for 20 years, or up to 35 cents a kilowatt hour 20 years from now. It's kind of a no-brainer. And so just going to like the project by project level, I included some fun photos. So this is a family, I think he's a Unity professor and his son. They sort of got into solar doing this fun little DIY solar project for school. Then they said, well, you know, do you have a question? And so anyways, they ended up getting into solar to do it for the whole house after this one little project. So that's, you know, this, you can take a conventional Maine home and by the addition of solar, hot water, and electric panels, that home is, I think it has a wood boiler as well. That's now carbon neutral. It's gone from guzzling gigantic blobs of CO2 each year to having no footprint. So again, just to go back to the visuals, you know, a typical 5 kilowatt system is eliminating 5,000 pounds of CO2. If CO2 is gigantic, globular, and tarry, that's what it would look like. And that's inaccurate to scale. So I just have a couple more minutes. I'll just go through some slides. This is a net zero structure, the geologic home in Belfast. So it has large passive solar on the south side. It's very well insulated, so it doesn't waste a lot of heat. It's able to generate electricity using the solar panels, and then it has hot water backed up by electricity. So if they're not using solar hot water directly to heat their water, they have electric backup powered by the sun. This is here in Portland, the Redfern House, a LEED Platinum house. This is one of our staff members who has a very ordinary conventional home, but by putting in a pellet boiler, putting in hot water panels and electric on the roof, he's again become net zero. He made an initial investment, but now he has no more utility bills, and he has no more carbon footprint, effectively, for his house. We also have pellets as an option. So our sister company, Revision Heat, has just started importing these kettle boilers. They're at a slight cost premium than an oil boiler. The fuel is half the cost, and the amount of CO2 goes from the big blob on the left to the big blob on the right, the little blob on the right, by switching from embedded carbon that's several million years old, to burning carbon that's, you know, a couple decades old in the form of pellets. So again, this is something that the Europeans are decades ahead of us on, but we are starting to be able to affordably, cost-effectively import their technology and make it work for our region. And given that Maine has still is pretty forested after 100 years of pulp and paper industry, pulp and paper's in decline, this is a wonderful application of those forest reserves. And again, another shout out to Unity College. This is a one of their buildings that has gone net zero with a photovoltaic on the roof and a pellet boiler in the building. I just thought this was, of course, this is a PPA project we did for a local therapeutic riding center. Hot water, this is the Bowden's Thorn Dining Hall. Huge bulk of that, and a big part of the step to their CO2 and carbon neutral campus goals is by eliminating the CO2 from natural gas in this building. This is UNE, again, these big hot water collectors. If you see over on Oakhurst, they've got a big similar system to this big flat plate hot water is a great way for facility level hot water to be generated. This is just a tracking system in the field. And finally, we now have the ability to have a carbon neutral transportation system with electric vehicles combined by photovoltaic technology. So this is still very much, this is the new kind of early adopter kind of technology, because the cost of electric cars is still, still out there. But from someone converting from who drives a lot, who's driving a SUV around, the economics of a Chevy Volt are actually pretty compelling. If you look at owning your source of electricity and not having to buy gas. So, to wrap it up, this is just sort of an analysis of what our resources are, and the solar resource on the planet is so vastly larger than any other resource that we have. It just seems insane not to put it to work. And that little blob is our actual world energy consumption. If we just put the effort forward to capture the sun and use the technology that already exists, we don't need to wait for technology that's 20 years from now. We have the stuff to do this already. We just need the will to do it, really. So that's my thing. Thank you.
I have a question for you. How is the expansion of natural gas in Maine, to the extent that it's already been expanded, how's that affecting the solar?
Well, it's not helping. So you asked about natural gas. I think natural gas is artificially suppressing the cost of electricity. Though what we've seen is that the promises of natural gas dropping cost is not really true. Like just because of our lack of throughput on pipelines, the cost is actually rising as opposed to dropping. So it seems to be, it's very much a band-aid kind of fix. So the thing that does concern us about natural gas is that it suppresses the interest in renewables because there's this whole idea that it's the panacea to all our problems. But so far it hasn't lived up to its promise of being super cheap and totally environmentally benign. So that's something that's kind of important to us to help reveal as a truth.
With the Quebec Hydro and the governor's plan to move above the 100 megawatt, how will that affect us?
That's also, it's fine that Quebec has this hydropower, but I think to us it's a symptom of continuing this direction of big centralized power systems as opposed to smaller micro generation distributed smarter power systems. So it's so it seems it's sort of the amount of energy it's going to take, and not just actual electric carbon generation, but the willpower and the project planning power to get that kind of get Quebec's hydro, move it here, could drive some very significant renewable investments that we would actually own and actually have local to our region. So that's again, and you look at what they're trying to do, the Northern Pass in northern New Hampshire. There's still this vision of huge power distribution center, of transporting large amounts of electricity from centralized sources as opposed to generating it where the power is needed, saving both the woods as well as putting the power where it's needed. So that's it's not probably quite as directly damaging to us, but in terms of the bigger picture of what we do on a utility scale, it seems like it's again the wrong direction. You know, it's a very 1950s kind of approach to the problem.